Hello everyone. Welcome to this lecture on particle in 3D box. In this lecture, I am going to discuss applications of particle in 3D box model. The first application that I am going to discuss here is Jahn-Teller distortion. Okay, let's get into the topic. So the first application that I am going to discuss is Jahn-Teller distortion. See, H.A. Jahn and E. Teller introduced this idea of distortion in the year 1937. This distortion is observed in molecules which are nonlinear, having high symmetry, and it is observed when an electronic level has degeneracy. So it is usually observed in degenerate electronic states. Okay, so Jahn-Teller distortion is observed in nonlinear molecule having high symmetry, usually in octahedral molecules, tetrahedral molecule, etc. And this effect is observed, okay, when we have degenerate electronic states. Okay, so this Jahn-Teller distortion is observed in these cases. Okay, and in the case of linear molecule, we have Renner-Teller distortion. I am not going to discuss Renner-Teller distortion in this lecture. In this lecture, I am going to focus only on Jahn-Teller distortion. Okay, what is actually distortion? Distortion is actually here, distortion means geometrical distortion, where some bonds may undergo elongation, some bonds may undergo compression. So here distortion that I mean, okay, the distortions are maybe elongation of geometry or compression of geometry. Elongation of bond or compression of bond. Okay, yeah, why this distortion occurs? What is the result of the distortion? Okay, the result of the distortion is energy of the system decreases. As we all know that when energy decreases, then stability will increase. Okay, so due to Jahn-Teller distortion, energy of the system decreases, therefore stability of the molecule increases. So this distortion is very common in nonlinear molecules. Okay, then not only that, due to distortion, the highly symmetric molecule, okay, goes to lower symmetry. So symmetry of the molecule decreases. Not only that, if the molecule has degenerate electronic level, then the degeneracy of that level also decreases. Right, so degeneracy also decreases. Right, this is the idea of Jahn-Teller distortion. Jahn-Teller distortion is observed in nonlinear molecule having high symmetry. Okay, and because of the distortion, if you have degenerate electronic states in a molecule, that degeneracy get reduced. Right? Yeah. Now, okay, what is the need of quantum chemistry here? Yes, quantum chemistry will provide you, will give you the proof that yes, energy of the system decreases and degeneracy of the system decreases. Okay, yeah. So here we are going to show you. Here I am going to show you how the energy of the system decreases and degeneracy of the levels decreases. Okay, using the particle in 3D box model. Right. So here I am going to take particle in a cubical box very specifically, right, where the potential energy is infinite outside the box. Okay, because why I am choosing this condition? Because I want the particle to be inside the box only. It should not escape out. Okay, so I have a cubical box here. Let's take this corner as origin, and I'll take this axis as x-axis, and this axis as Y, and I'll fix this as Z axis. Okay. Now, since it is a perfect cubical box, the x-axis intercept is L. Let us consider this as L, and the y-axis intercept also L, z-axis intercept also L. So length, breadth and height of the box are same. And now let us consider a particle, right, preferably electron, is present inside the box, because we are going to see electronic degeneracy, so I will take electron inside the box. Okay. Now in order to understand energy of the system decreases and the degeneracy of the electronic level decreases, let me choose a particular energy level. Say for example, I'll take this energy level. You know very well that for particle in a box, the general expression for energy is nx square plus ny square plus nz square times h square by 8ml square. Okay, this is the energy expression for particle in a cubical box. Okay, and you know very well nx, ny, nz, they are all quantum numbers. In a box problem, quantum numbers can take value from 1, 2, 3, 4, etc. Okay, it starts from 1, right? 0 is not allowed here, right? Now in order to understand the Jahn-Teller distortion, I'll choose a particular energy level. Okay, say energy 6 times h square by 8ml square. I'll take this level. Okay, so this is the energy axis. Right now I'm choosing a particular energy level whose energy is 6 times h square by 8ml square. Now for this given energy level, how many degeneracies are associated with this? Okay, so if I place the quantum number nx, ny, nz, right, isn't this value, that is nx square plus ny square plus nz square, supposed to be equal to 6. Okay, to get that value 6, what are the possible numbers that these quantum number can take? Okay, one possibility is nx can be 2, ny can be 1, ni and nz 2, 1. So if you take square of these numbers, 2 square is 4, 1 square is 1, 1 square is 1. If you add them, you'll get 6. Right? This is one combination. We have other possible combination. What are that? nx can take 1, ny 2, nz 1. This is another possible combination. And we have one more combination. What are that? 1, 1, 2. See, this corresponds to one wave function. This corresponds to another wave function, and this set corresponds to another wave function. So what I'm trying to say here is, this energy level 6h square by 8ml square, okay, has 3 degenerate electronic states. Yes, we have 3 degenerate electronic states. What are they? State 1 has the quantum number 2, 1, 1. State 2 has the quantum number 1, 2, 1. And state 3 has the quantum number 1, 1, 2. So here in this state, the quantum number nx has the value 2, ny has 1 and nz has 1. In the second state, nx is 1, ny is 2, nz is 1, like that. Okay, so now listen, this level 6h square by 8ml square, this electronic level, this energy level, this energy level has 3 degenerate states. Okay, so degeneracy, we usually represent degeneracy by the symbol G. So what is the degeneracy of this level? Degeneracy of this electronic level is 3, because we have 3 states. Okay, now listen, this is a perfect cubical box. So there is no distortion, nothing, right? So before distortion, right, let me say this is before distortion. Before distortion, this energy level 6h square by 8ml square has 3 states, has 3 degenerate states. Okay, yeah. Now I'm going to make a distortion in this box. See, I'm going to make some geometrical distortion. Distortion means you can either elongate the geometry or you can compress the geometry. Okay, so what I'm going to do here is I'm going to distort this geometry along x-axis. Okay, so what I'm going to do, I'm going to elongate. Yeah, this is the original position of the box. This is the original position of the box. Now this length is L, that we know already. Now I have elongated, so this is the x-axis and this is y and this is z that we know. Now what I have what I did here is I have elongated the box, right, along x-axis. I have elongated the box along x-axis by a small distance dl. Okay, so this is x-axis. Listen, y length and z length, they remain same. Length along y-axis, length along z-axis, they remain same. So distortion is occurred only along x-axis. Okay, now because of this distortion, what happens to the energy of the system? Okay, whether the three states, 2, 1, 1 state, 1, 2, 1 state, 1, 1, 2 state, whether these three states remains with the same energy or is there any decrease in energy occurred? Okay, so that we are going to discuss using this distortion. So here I have distorted the molecule along x-axis. Okay, so distortion along x-axis. Distortion. I have carried out distortion along x-axis, right? Specifically elongation. I have elongated the geometry along x-axis by a distance, by a small distance dl. Right? Now, now what will happen to the energy of each state? Okay, so let me take the first energy state psi 211. What will happen to the energy of this state? Okay, yeah. So before distortion, the energy of this state can be given as the nx quantum number is 2, so 2 square is 4, h square by 8 ml square. Okay, then plus ny is 1, so h square by 8 ml square. nz is also 1, so h square by 8 ml square. Okay, and if you add everything, you will get 6h square by 8 ml square. This is the energy of 211 state before distortion. This is before distortion. Now after distortion, what will happen? Okay, I have elongated the geometry along x-axis by a small distance dl. So because of that, what will happen? There will be a change in the energy of the system. So if you add that change, in energy with the original energy, you will get the new energy of the system. Okay, yeah. So for this, what I'm going to do, so we have to keep the original energy as such first, right? So in the original energy, we have 4h square by 8 ml square. Okay, then see here we have distorted the geometry along x-axis. So the x component of energy, that is this energy, the x component of energy, okay, should be changed. Okay, so what I'm going to do, to find the change in energy in the x component, we have to differentiate this. So I'm going to differentiate, okay, this energy value 4h square by 8 ml square. Okay, and there is no distortion in y and z, so I'm going to keep them as such, h square by 8 ml square plus h square by 8 ml square. Okay, yeah. Now okay, now I'll differentiate this separately and I'll substitute here. Okay, let me take this as equation A, right? Then so what we have to do, we have to differentiate this. That is differentiation of 4 times h square by 8 ml square. 8 ml square. Okay, so here 4 is constant, h square is constant, 8 m everything is constant except the length. So we'll get 1 by L square. So we have to differentiate this. Keep this 4h square by 8m as such. If you differentiate 1 by L square, we will get minus 2 by L cube. 1 by L square and differentiation will give minus 2 by L cube into the differentiating term dl. Right? So 4 into 2 is 8. 8 by 8 get cancelled. So you will get minus h square by m L cube into dl. Right? This is the change in energy due to the distortion along x-axis. Okay. So what is the new energy of the 2-1-1 state? The energy of the 2-1-1 state, I'll put it as E prime, is a new energy, which is nothing but the original energy of 2-1-1 state plus original energy of 2-1-1 state plus change in energy dE. Okay. So that is you substitute this in equation A. So what is equation A? I have given this 4h square by 8ml square. Then we have to add this change in energy in equation A. So you will get minus h square by ml cube into dl. Then y component of energy and z component of energy should remain same. Okay. So y component of energy is h square by 8ml square and z component also h square by 8ml square. We should keep this as such. Now if you add these three, we will get 6 h square by 8ml square. This is the energy before distortion. Then minus h square by ml cube into dl. Okay, this is the change in energy due to elongation along x-axis. Okay. Now if you observe this carefully, in elongation, if you elongate, in elongation the dl will be positive. If dl is positive, see here we have negative sign, so positive into negative become negative. That means we have to subtract this much energy from the original value. So if you subtract, what will happen? The new energy of the system will decrease. Okay, so this clearly shows that due to elongation, okay, energy of the system decreases. Whereas if you carry out compression, right, in compression, okay, in compression dl should be negative. If dl is negative, then negative become positive, so energy of the system will increase. Right? That is why in Jahn-Teller distortion, the very common distortion is elongation. Okay, because in elongation, energy of the system decreases. Okay, therefore stability increases. Right? We all know that most molecule tries to goes to more stable state. Okay, so in order to approach or in order to attain more stable state, right, they try to reduce the energy. Right? That's why if you see Jahn-Teller distortion, in most examples of Jahn-Teller distortion, elongation is the common one. Right? Then, okay, so this is the new energy of the 2-1-1 state. What about the other two states? Okay, so now let me take the energy of the next I will take this state, that is psi 1-2-1 state. What is the energy of this state? Energy of the state is given as nx quantum number is 1 here, ny is 2, nz is 1. So the energy is h square over 8ml square plus 4 times h square over 8ml square plus h square over 8ml square. Okay, this is x component of energy, this is y component, and this is z component. This is the energy. So what is the total? Total is 6 times h square by 8ml square. This is the energy before distortion. Okay, this is the energy before distortion. Now what I am going to do, since we have distorted the geometry along x-axis, okay, there will be some change in energy. Okay, so this is energy of the state 1 to 1 before distortion. So energy of the state 1 to 1 get changed by an amount dE due to distortion. Okay, so what is that? H square by 8 ml square. This is the energy of the x component. Now there will be a change in the energy of the x component due to distortion along x-axis. So the change is for the change you have to differentiate h square by 8 ml square. Okay, plus keep the y component and z component as such because there is no distortion along y and z. Okay, so we have to differentiate this, and we have already differentiated this. Okay, anyway, I will do it once again. So I will take that because there is a small difference, no? So we have to differentiate once again. Here see h square is constant, 8m everything constant. So we have to differentiate 1 by L square, right? So h square by 8m, keep it as such. Differentiate, if you differentiate 1 by L square, we will get minus 2 by L cube into the differentiating quantity dl. Okay, so if you simplify this, 2 2s are 1 2s are 2, 4 2s are 8, so you'll get minus h square by 4, this is 4m L cube into dl. Okay, so due to the elongation along x-axis, okay, the energy of 1 to 1 state, right, get modified slightly by this amount, minus h square by 4 ml cube into dl. Okay, so if I substitute this here, okay, then the new energy E prime for 1 to 1 state, right, the new energy is nothing but original energy of 1 to 1 state before distortion plus change in energy, right? So which is nothing but, okay, see, we have to substitute this energy, okay, here, then add everything. Okay, listen, here I have h square by 1 h square by 8 ml square, 4 h square by 8 ml square, again 1 h square by 8 ml square. If you add, you will get this is equal to, you will get 6 times h square by 8 ml square. We know that this is the energy before distortion. Okay, then the change in energy due to distortion is minus h square by 4m L cube into dl, right? So this is the new energy of the state 1 to 1. Okay, now similarly if you carry out distortion, if you carry out similar calculation on psi 112 state, psi 112 state, you will get the similar expression. Okay, so I am not going to do that. Similarly, we have to do the calculation in a similar manner. So similarly, you perform. So the energy of the 112 state after distortion is equal to energy of the 112 state before distortion plus change, and this comes out as 6h square by 8 ml square minus h square by 4m L cube into dl. Okay, so it is very clear that energy of the 211 state, 121 state and 112 state, the energy of all the three states decreases, okay, in elongation, right? Energy of all the three states decreases in elongation, right? But the decrease is not same. Okay, what is meant by that? Listen, let me write everything once again. Listen, so the new energy of 211 state is given as 6h square by 8 ml square minus h square by ml cube into dl. Okay, and the new energy of 121 state and energy of 112 state, these two are actually same. Okay, if you want to just go and verify that whether the two expressions are same or not. Okay, 121 state and 112 state, right? These two states, the energy of these two states are same, which is given as 6 times h square by 8 ml square minus h square by 4m L cube into dl. Now listen, energy of 211 state decreases, energy of 121 and 112, all the three states, right? Energy of all the three states, states decreases, no doubt in that. Okay, decreases in elongation. So if you elongate, energy of the system decreases. If energy decreases, its stability should increase. Okay, now listen, now I'll give you the decrease in degeneracy. I'll show you how to do that, how to understand that. See, before distortion, the energy of 6h square by 8 ml square, this level has degeneracy 3. This is before distortion. Okay, this corresponds to 211 state, and this corresponds to 121 state, and this corresponds to 112 state. All the three states have same energy. Okay, so degeneracy of this is 3. Before distortion, degeneracy is 3. Now, due to distortion along x-axis, right? Due to distortion, right, along x-axis. Okay, very specifically, I have carried out elongation, right? Due to elongation along x-axis, what happened was, see, this is the energy level of 6h square by 8 ml square. Okay, this is the original level before distortion. Now what happened was all the three states, okay, the energies of all the three states get decreased, right? Now if you observe this carefully, see, here we have h square by ml cube, here we have h square by 4 ml cube. In these two, which is higher? See, here we are dividing by 4. So this is low number, this should be a high number. We are subtracting, see, we are subtracting a high number from this 6h square by 8 ml square. That means the resulting energy will be very, very low. So because of distortion, the 211 state will go to very low energy value, right? Whereas 121 and 112 states, where this value is low, so you are subtracting a low value from this number, from the same number, is 6h square by 8 ml square. So here also the decrease is there, but the decrease is somewhat less. Okay, but the 121 state and 112 state, they remains degenerate even after distortion. Okay, but if you see the degeneracy of this and the degeneracy of this, okay, listen, original degeneracy is high, but now after distortion, degeneracy is not 3 for any of these levels. Okay, degeneracy become 2. Okay, degeneracy became 2 and 1. Right, so what does it indicate? It indicates that degeneracy of the electronic level also get decreased. Right, so these two states decreased by an energy 6h square by 8 ml square minus, so this is the decrease. Okay, let me take this value as say x. So these two states decreased to an energy of amount x, and this state decreases by an energy of, okay, let us take this as y, by an amount y, right? Yeah. So based on particle in cubical box model, right, we could understand, right, how the elongation of the geometry increases the stability of the system, right, as well as how the degeneracy of the electronic level get reduced. Okay, yeah. So I stop here. We'll continue with the second application, right, in the next lecture. Thank you once again.